YouTube. You know what time it is. If you know this channel, just by seeing these parts here alone, you have an idea of what's about to go down. Propane tank, magnetron, transformer, and capacitor. Something is about to be put together by these components. Just saying. Don't know what. Somebody is going to build something that has all of these in common. What's up, guys? What's your boy NatureJAB building today? I'm building a small demo presentation reactor, a reactor I can take with me to places. It's got to meet a few criteria. It's got to be small and portable. Got to be able to fit it in the boot of my car, the trunk of my car. It's also going to have to run off of 120 volt electricity because most places here in the States, we don't got 220, so I gotta make it run off of the low voltage 120. Well, it's not really low, but anyways, it's also gotta be safe and user friendly. No explosions, no fires, no nonsense, no shocking electrocution. We gotta make it as safe as possible. Not that anybody else is gonna be using it, but sometimes people want to. Lastly, it's gotta look bad at monetization, but it's gotta look cool. There's no excuses for that. People are going to see this. It's going to be shown, recorded. It's got to look cool. So anyways, let's get to it. As you saw, we started with a propane tank. So we're just going to have this cylinder here to represent the propane tank. The first thing we need is an inlet and outlet port, a flange. That's what this is here. This is going to be our feed and our discharge of plastic and of the resulting byproduct of the reaction, which ends up being carbon. So from there, we load in the plastic at this angle. So I have this port at this specific angle because it's going to serve two purposes. We can load in the plastic easy, but the whole thing can be picked up and tilted over at the end of the reaction. As you see, the carbon is going to come out pretty easy too. No big deal. So what else do we need? If you guys know NatureJAB, you know what we do around here. All the pyrolysis we do uses microwaves. So that box that you see added is going to be a waveguide, or basically a barrel for microwaves. So I'm going to draw a little diagram of the microwave radiation coming off. So as you see, at that angle, it's going to come out and pretty much have coverage over the whole chamber. Microwaves also bounce off of metal, so with it bouncing off the walls, it's going to pretty much have coverage over everywhere. It's going to be an absolute gangbang for the plastic in there. So we put the plastic in there and looks good, right? Well, there are some issues here. So yes, we put plastic in, loaded, microwaves turn on, it's good. But here's the issue. Plastic, once it breaks down under microwaves, ends up becoming carbon, and carbon is super microwave absorbing. So the top layer of the plastic ends up turning into carbon, while the bottom actually is pretty much protected by the impenetrable barrier. Now, for those of you that remember my Mark II microwave pyrolysis reactor and my Mark I, actually, this was actually the biggest issue. As you see, it's very similar. That's a picture of it up there. It was a small chamber, cylindrical, same as this pretty much. And that was the biggest issue we always had. I would call it lack of complete carbonization. Just the top layer of plastic would be broken down, but under that we'd have more plastic. So how do we solve this problem? Agitation. Gotta add blades. Gotta go Vitamix Ninja up in this piece. So what do we do with that? Well, we add these blades up in here, and what these blades are going to do is they're going to be able to spin the plastic around, allowing maximum surface area with microwaves at all times. So like one piece of plastic breaks down into carbon, well then we turn the blades and it gets to the next piece until it all breaks down. So making this a little bit more complex now, I added a hand crank and some of the plumbing. What we're going to do when you add blades, it's not just as simple as you just add blades. It's actually quite some engineering, because you have to think about, okay, I have blades, but how can I turn the blades? How can I get enough torque on them to turn the plastic when it's melted and sticky? And also, how can we keep it airtight? How can you rotate something and keep it airtight at the same time? That's a little bit tough. You got to do things like mechanical seals and all of this. So as you see, I actually incorporated the shaft of this blade into the plumbing, the exhaust plumbing, because for those of you that are new to this process, the plastic goes in here in this oxygen-free environment, is heated by microwaves, and ends up creating a gaseous product. It becomes a gas. So we need to keep it airtight. No leaks are even possible. So going on from there, the plastic becomes a gas or a vapor, right? Petroleum basic components goes up the pipes and is going to enter the condenser. And then the condenser is going to, just like how clouds turn into rain, it's going to turn the gaseous product into oils, and then the rest of the uncondensable gases will go out the exit port to be captured or flared or whatever, etc. So why am I building this? Well, I'm building this, guys, because I think that podcasts are cool. I think that presentations are cool. But you know what? People want to see even more than any of that. They want to see an actual functioning reactor. They want to see this actual technology, even if it's at a small scale, even if we're just producing little piss pints or ounces of this bloody fuel or whatever. I think that's cooler because people can always imagine it at a bigger scale versus just kind of it all being theory on paper and stuff. And I'm that way too. I like to see. I'm a tangible person. I'm a doer, pain and gain up in here. So that's why I'm building this, so that way I can have something. And also, I haven't built something in a while, and I want to build something. So with that being said, I'm done talking. Let's get to it. Let's get it started in here. So the first thing you gotta do when you have a propane tank is you gotta remove the valve, because you gotta make sure all of the propane is out before you weld or you cut on it, because otherwise there's a risk of fire, potential risk of explosion. Now this propane tank I picked up from the scrapyard, it's pretty much bone dry. There's still residual propane, but it's pretty empty. So taking off the valve, I've taken off the valve on 3 propane tanks total in my life, and they've all been pretty simple. You strap down the propane tank and you just put a little bit of leverage on it and it comes off. But I will say this propane tank in particular has given me so many issues, and maybe it's because it's a little bit older or bad luck, but this propane tank, I could not get this valve off for the life of me just using my conventional methods. You see, I ratchet strapped it down to this column here. And in the past, I mean, I used to ratchet strap down the propane tanks to just my tree. And, it'd be easy. Sometimes I could just get away with just putting one ratchet strap on. That was not the case for this bad boy. I would crank this thing down with all the leverage I could put into it, and it would just end up moving the propane tank before it would actually dislodge the valve. So it was just back to the drawing board. I decided, okay, I need more leverage. I need an easier way to access it. So I did something very dangerous. I actually went ahead and I cut part of this handle off while this tank, still has residual propane in it. So I don't recommend this to anybody, but I did take some precautions before I did this. First of all, I do have a face shield on and all this stuff in the case of, let's say, a small depressurization were to happen, but also I really made sure that I cut the handle and not the tank. The tank is made of metal, so the sparks can't access the propane unless you cut into the tank itself. And after that, I also made sure the valve, all the propane I could get out possibly was empty. That wasn't enough though, so I had one more little method under my hat, one more little ace card in the hole, whatever they want to say, which is using this big ass pipe right here, getting as much leverage as I could. That didn't work either. Something's wrong when the pipe method doesn't work. The pipe method works with everything. So what's better than the pipe method? The Mario pipe method. Mario's little plumbing wrench with the pipe. That wasn't enough. Once again, it would move the propane tank before it would freaking move the valve. And maybe it's because my trash ratchet strapping, but nonetheless, I was fed up. I had been working on this all day and I could not get the freaking valve off. So you know what I said? I said, okay, I'll do it my way. I'm going to drill a hole into this tank. Now, once again, this is pretty dangerous. If there is a sufficient amount of propane left in the tank and you drill a hole, the minute you drill that hole, there'll be a massive depressurization. It's going to form a jet of propane that will shoot out. And of course, if that finds a spark, that will explode. Or even more likely is, if it's enough pressure, it'll just form a jet that will literally send this propane tank flying, maybe at you, maybe at somebody. So I don't recommend this, but like I said, I made sure all the propane was out. And gave me a little bit of a torque on that thing, you know what I'm saying?
Oh wow. That's funny.
So the point of me drilling this hole is, when you take off the valve of a propane tank, what you do next is you then fill it with water. Because when you fill it with water, you're able to get all of the residual propane vapors and propane gas dissolved into the water, and also push it all out because the water would displace it. So that's what the water does. That's why we do this.
Say that again.
Somebody's having a wet night.
So what happens if I grab a lighter and throw it at them?
Nothing's gonna happen now. All the propane is gone. Yeah, get a shot of that water. Oh, it didn't explode. It didn't blow up. You're lying. So after rinsing it thoroughly with water, now it's safe to cut, to weld, everything you want to do. You don't have to worry. All the propane has been displaced. There's only very small residual propane, not enough to make any type of explosion. At most, just a small fire within the tank. So now I'm just going ahead and cutting off the rest of this handle, hassle free, no worries. And after that, this is where my ingenuity steps in. So the valve, we could not twist it off, but I need it off for my design. As we saw, this is going to be where the exhaust port comes out for the gas and where the shaft of the agitator will be. So I said, you know what, F the valve, I'm just going to cut it off. And that's exactly what I did. It's only made of brass. I mean, if I can cut steel, I can certainly cut brass. And so that's what we did. We cut this valve off, and it was actually very interesting to see. I've never cut a valve before. It was interesting, but ultimately it just turned out to be pretty simple on the inside once it was cut. And you're about to see that here. So as you see, it was just 2 holes in one. You know, all in one here, a little cloaca. So anyways, with it being brass, I knew it was brass. Brass melts at a lower temperature than steel, so I figured, okay, I can just cut out the valve and literally just melt away the brass, and it's just going to fall into the tank. Easy. So that's what I did here. I got a little oxygen acetylene torch, and I just figured we just concentrate the heat there for a little bit. Eventually the brass will start melting away. I won't lie, cutting this was a little bit scary. Even though I filled the tank with water, putting a flame like this, a source of oxygen and fuel, literally into a tank that used to just have pure flammable gases was scary. You know, and I did kind of hesitate for a little bit in the beginning. So when the brass started melting, it started to form this green fire, and I think it's because of the copper in brass, because you know brass is an alloy of copper and what is it? Something else. Anyways, I think it's like copper and tin or something like that. But you see, it was making these smoke and all this like that. It was gassing out, and it was a little bit scary because like just thinking that any moment that could be an explosion. You know what I'm saying? But I knew I was safe at the same time because I went through the procedure to get all the propane out. So anyways, unfortunately, some of the brass ended up getting stuck onto the threads. I wanted to save these threads because these are actually 3/4 NPT threads, so I could just easily get a 3/4 NPT nipple and just screw it into there, but I wasn't able to preserve the threads. It was too much, and if I were to go through the process of like trying to scrape off all the brass, I'd probably damage the threads anyway. It wouldn't be airtight anymore, so I figured I would just weld on a 3/4 nipple. I'm gonna take this flange and make a door on the side here. So to do that, I'm gonna have to cut a hole the size of this pipe to fit the flange on the side. I want it a little bit angled up though, so maybe like that. But first, we're gonna cut off these threads. You know what I'm saying? So at this point, I'm just cutting off the top flange, or where the threads used to be, because we're not going to be using them anymore. And then I was trying to drill them away to make the hole a little bit bigger, but it turned out not to really be useful right now. Maybe a little bit later when I'm actually going to screw in the nipple. that may be more practical. You make that hole bigger so I can, you know, bring it as close to the tank as possible. So I'm just grinding away the paint here to prepare the surface for marking with the pipe. And I'll tell you now a huge mistake I made. So you see I'm marking this pipe with a marker. I'm going to be cutting this out with an oxygen acetylene torch, not a plasma torch. Usually when I'm doing the plasma torch, you can get away with marking it with a marker, but when you do it with an oxygen acetylene torch, it burns away the marker. So in the middle of me cutting this circle, I could no longer see the lines, and I ended up cutting the hole too small, which then you're going to see what kind of happened from there. But in the meantime, it does look pretty cool to cut. It looks like Star Wars, you know, especially when you speed it up. You just see the metal kind of melting away. It's cool. I also should have set this thing on its side because it was kind of really awkward to get the angle when I was coming downhill with it and then had to go back uphill. So I should have done those things. You see the hole is a little bit smaller than I wanted here. And it's not a perfect circle because I'm not a perfect person, but I'm also not the best torch cutter in general, especially vertically. I'm a lot better if it's horizontal. So I went to expand the hole, and then it just kind of ended up making the hole even more ugly, where now we have this little gap on the side, like we're a store clothing brand, you know what I'm saying? But I figured it'll all be okay because if there is one thing I'm good at, it is horrible pipe fitting and filling big gaps, because I've done that in every single one of my reactors. And yeah, so anyways, don't you just love cancer? I love cancer. I just love this cancer dust on this paint. In this paint on this pipe. I ground all of that away before I got to cutting the pipe. You know, I had my respirator on and all this. What is that type of paint that's on all these pipes? It's so thick. So anyways, I wanted to make a straight cut because I know I wasn't going to do it by hand at this right angle. So I used a chop saw and then this happened. Yeah. F the chop saw. So obviously that was user error. But I just decided I'll do it by hand. It's all right. Of course, I could have strapped it down better, or maybe could have used some mantis clamps. But at that point, I was like, I'll cut it by hand because you know what? This thing is gonna be imperfect anyway. Because even if the cut on the pipe is perfect, my cut on the propane tank was trash. So there's no way we're gonna get this pipe fitting good. You know, any pipe fitter watching this is the worst, your worst nightmare right here. You've never seen a fitting this bad in your life. And you know what, guys? I'll be honest. That pretty much is my biggest flaw, my biggest downfall with things. I don't have the precision cutting tools. You know, like the big band saws and stuff. And I myself don't have the precision cutting skills to cut something straight by hand. You know, so that I don't let it hold me back. You know, I build things anyway, but I have to deal with a lot of nonsense, like huge gaps or having to recut something 30 times. But so just imagine what I can do when I do have the precision cutting tools, because you know what, most of welding is the cutting and the fitting more than anything else. So anyways, I'm welding this with 035 spray arc. I know a lot of people are going to think, why spray arc? Well, it's because it's what I have at hand. It's what I had in my welder. And also, I don't carry around a bottle of argon. Spray arc, when done properly, gets the same penetration, gets the same tie-in. It's pretty good. It's not as pretty. It's an uglier weld by nature, especially gasless flux core. But as you see, when you hit it with a wire weld, it's not bad. And all that matters more than what the weld looks like is that it's airtight and that it's properly tied in. So that's what I focus on more than anything with flux core. So yeah, I mean, I've welded almost all of my reactors with the flux core, and even when I've had reactors explode and catch on fire, the weak point was never the welds. It was always some other factor, because the flux core is pretty good. It's really strong. It's really strong stuff, and a lot of heat can get through it. I noticed that it penetrates very well and very strong. It ties in very well, and also it's not as picky about if the surface is 100% clean, which is kind of good. So as you see, I had this huge gap, and I just took my time. I have this thing sped up literally by 5,000% because it took a long time to fill in that gap, but it was possible. So once I just filled in that gap, the point of that weld was just to fill it in, not to be pretty, not to tie in, literally just to give me space to put on my next welds. Then I did 3 pass welds, 1, 2, 3, pretty much almost as like a cap over that kind of initial root pass. And you know, once again, like I said, these welds certainly are not pretty, but they do tie in and they do work out, and they're going to keep this thing nice and airtight because I did so many. I had my heat high. So that was that. We did those welds. We got the flange welded on there. This is the first step to victory, guys. We're almost there. How's it looking? Thank you for watching. Your boy NatureJAB. Gonna see you in part 2. Let's go.